Assalamu alaikum wa rahmatullahi wa barakatuh. Dear student of second secondary, we are going to solve questions of Egyptian Knowledge Bank, Chapter 3, Bonds and Forms of Molecules. Let's start with the first part of our questions, types of chemical bonding. In this part, we will practice describing different types of chemical bonding, understand and the concept of valency, and representing chemical bonds using Lewis structures. Okay, we have different questions today. We have parts. We will solve today 10 questions from this part of Egyptian Knowledge Bank. Okay, let's start. Okay, first question says that the valence shell of boron is the second electron shell and contains 3 electrons. How many covalent bonds can boron form by sharing its electrons? Okay, if we discuss the structure of boron as an element, we have 3 electrons in the valence shell. Okay, and it is the second one. Okay, so if we discuss the boron and we want to make the Lewis dot diagram for it, or we want to know how many covalent bond to make that it will be make. Okay, at first, if we have this example for boron, we have here 3 atoms of fluorine, so the molecule formed here boron trifluoride or boron fluoride. Okay, so here we have 3 electrons in the outer valence shell, so we will make 3 covalent bond. Okay, so it will make 3 covalent bonds. Okay, this structure indicates the instability of compound as it make a resonance for the compound, but at least we want to know how many bond it will form from this structure. As example, boron form 3 covalent bond. Okay, so how many covalent bond can boron form by sharing of its electrons? It form 3 bonds. Okay, this is the first question. I give you this drawing for illustrating how we can draw Lewis dot diagram or Lewis dot structure. Okay, let's go to question number 2. Okay, question number 2 says that hydrogen has a single electron in its valence shell. How many covalent bond can it form? I think it's easy. Here we have the structure of helium. Hydrogen and helium follow deuterol, as it contains 2 valence electrons. They have a small outer shell, so it will have one or single covalent bond. It will form one bond or it has a single covalent bond. Here the structure of one hydrogen atom and the other hydrogen atom. The line represented what here? A pair of electrons. If we make dot like this or straight line between the 2 hydrogen bond, we mentioned that we have here a single covalent bond inside the hydrogen molecule. Okay, what is the difference between Dawit rule and octet rule? Octet means 8 in the Roman language, and Dawit mean 2 in the also in the Roman language. Okay, so we have Dawit here as they have only 2 electrons in the outermost energy level or in the valence shell. Okay, so here we have the structure of what? Of hydrogen will form one covalent bond. Okay, let's go to question number 3. Okay, question number 3 says that The valence shell of oxygen is the second electron shell and contain 6 electrons. So oxygen is electronegative element as it has the ability to gain electrons. How many covalent bond can oxygen form? Okay, it need to gain 2 electrons, so it will make the structure here have 6 electrons each one. Okay, I will give you more than drawing for each element in our questions for remembering that we need to make the dot notation or Lewis dot structure. Okay, here oxygen make a double bond here, so it will make a 2 covalent bond. It will make a 2 covalent bond in the oxygen as it has what? It has 2 electrons needed to complete the valence shell in the structure or to reaches to octet structure in its behavior and become stable at end. Okay, so let's go to question number 4. Okay, question number 4 says that the valence shell of carbon is the second electron shell and contains 4 electrons. How many covalent bonds can carbon form? As it has 4 electrons for shell in the outer, here we have the drawing, the dot diagram for what? For carbon. Carbon contains 4 electrons in the outer and surrounds by 4 hydrogen atoms here, so it will have 4 bonds or 4 covalent bonds or tetravalent electrons or tetravalent bond, okay, to form this kind of bond inside the molecule here, as it make a sharing for these electrons to form the tetravalent bond. Okay, let's go to question number 5. Okay, question number 5 says that which of the following pairs of atoms are unlikely to form covalent bond? Okay, we have the first group here. We have pairs of atoms. The first one, neon and argon. Okay, the second one, nitrogen and oxygen. Third one, sulfur and chlorine. Fourth one here, number D, carbon and fluorine. And the last one here we have boron and hydrogen. Do you think all of them form a covalent bond? No. One of them unlikely to form a covalent bond or not form bond at all, as it's inert or inactive element in nature. So we have here the right answer will be what? The first one, neon and argon. Neon and argon are the noble gas or inert gas. They are the nearest element to be unformed any kind of bond as they are completely inactive. Okay, let's go to question number 6. Okay, question number 6 says that which of the following statement about chemical bonding is false? Okay, I put it in a definite color to remember that we have false, not right. Okay, which of the following statement about chemical bonding is false? We have the first one, in covalent bonding electrons are shared between atoms. Okay, it's right. Second one here, molecular compounds can only contain covalent or ionic bonding, never both. Okay, do you think it's wrong? Okay, another one, in ionic bonding electrons are transferred between atoms forming ions. I think it's right. Okay, the fourth one, D here, chemical bonding involves electrostatic attraction between oppositely charged particles. Okay, do you think what about it? And the last one here, in metallic bonding, a sea of delocalization or delocalized electron is formed. Okay, what do you think about the answer here? What is wrong about false of the bond? Okay, we have here the right answer will be molecular compound can only contain covalent or ionic bond, never both. Okay, it's wrong about this knowledge. This statement is wrong, as we have can form ionic or covalent. As we said in last session, can we change the ionic bond into covalent? Yes. Sometimes when dissolving the ionic compound, it will, like table salt, it will make dissociation or breaking the ion bond and form kind of bond between what? Between the solvent as water molecules. Okay, let's going to question number 7. Okay, question number 7 says that how many electrons does an atom of strontium lose when forming the ionic compound SRI2? Okay, when we are looking to strontium here, it will notice that we have here the chemical formula SRI2. Okay, so strontium here has 2 valence electrons and iodine has 1 valence electron, so they will make exchange here. So how many electrons does atom of strontium lose to form the ionic bond here? It will lose 2 electrons, that giving it to the 2 iodine atoms. Here we have the 2 electrons, each one giving to what? To the iodine atoms here. Okay, if we make electronic configuration for strontium and iodine, here we have 2 electrons in the outer shell, outer valence shell, and iodine have 7 electrons, so it's monovalent and need to gain 1 electron, so it will share 2 atoms of iodine, or giving the 2 electrons to 2 atoms of iodine. And how many electrons? 2 electrons of iodine, 2 electrons of strontium, sorry, can make what? Can make the ionic bond forming strontium I2. Okay, let's go into question number 8. Okay, question number 8 says that how many atoms of bromine are usually needed to form an ionic compound with a single atom of aluminium? Okay, we have the aluminium is a metal and the bromine is non-metal, so aluminium lose 3 electrons from its outer valence shell, and bromine need only 1 electron, as it is monovalent, non-metal, monovalent, non-metal, monovalent. So it will make the reaction between what? Between 3 bromine atoms here, as aluminium lose 3 electrons, so 3 atoms of bromine needed 3 electrons that lost by aluminium. So if we're looking at the structure here, we have here the lowest dot diagram. Okay, we have the lowest electron, it will be Al right above it plus 3, and bromine here we have 3 atoms of bromine, each one needed 1 electron here, as it surrounds by 7 valence electron. So if we mention that we have a bonded and non-bonded electrons in the lowest dot diagram, do you think here we have what is the number after making the lowest dot diagram? What do you think about the number of unpaired electron or unbonded electrons and number of paired electrons or bonded pair electrons. So if we have here 3 atoms of bromine, okay, please count, try to draw every question and try to count every question to reach the number right without any mistakes. Okay, the first one here, we have 3 atoms of bromine, so we have here 6 electrons, and we can mention pair. Okay, instead of the number of electrons, we will said we have a pair of electrons. So each atom of bromine has 3 pairs of unbonded what electrons. So 3 times 3 equal 9. Okay, we have 9 unpaired or unbonded pairs of electrons. This is the first one. And second one here, we want to know the number of bonded pairs of electrons. If we have 3 electrons in aluminium and 3 electrons in each boron atom, so we have 3 pairs of bonded what? 3 bonded pairs of electrons. 3 bonded pairs of electrons. So we have 9 pairs of unbonded electrons and 3 pairs of bonded electrons. I think it's easy question. Okay, at the end we have here bromine -1, bromine -1, bromine -1. So it's an electronic structure at the end, or dot notation at the end after what? After making an ionic bond. So I make training. I said to you I will make training for how to write or how to draw the dot notation diagram for Laos, and we must remember every question we have to do this to make the counting right. Okay, so the right answer will be 3 atoms here of what? Of bromine can make an ionic bond with aluminium. Okay, let's go to question number 9. We have here in question number 9 Lewis structure for a molecular compound of potassium and sulfur. We have here potassium, 2 atoms of potassium by losing two, each one losing 1 electron, and here is sulfur. Okay, as shown below, sulfur take 2 electrons to complete its outer valence shell, and here and right we have -2 on it. How can you tell this compound is ionically bonded? How can you tell us this is ionically bonded? Okay, we say that each potassium atom loses 1 electron and the sulfur atom gains the 2 electrons of each of each potassium. So we have choices here. The first one, ionic compounds always contain atoms in a 2-to-1 ratio. Second one here, the atoms of sharing electrons to obtain full outer shell but have not become ions. Do you think what? Number C, sulfur atoms can only form ionic bond. Number D, the atoms have either lost or gained electrons to become ions and obtain full outer shell. And the last one here, we have the atoms are surrounded by a sea of denuclearized electrons. What do you think about the answer here? Okay, so the right answer will be, how can you tell this compound is ionically bonded? The atoms have either lost or gained electrons to become ions and obtain full outer shell. Okay, so to reach what? To reach the octet shape or octet rule of diagram. Okay, it's an easy question. We have here the diagrams that showing the formation of ionic bond. Okay, let's go into question number 10. Okay, question number 10 says that which of the following is the correct Lewis structure for fluoride ion? Okay, let's see the drawing here. we have fluorine F8 and surrounded by plus. Okay, at first we have plus, it's wrong, and here we have what? This one without any sign, also wrong. Why? We need the fluoride ion. So we have three draws for the negative ion. The first one we mentioned, after putting the sign, we have to reach the dowet or octet. Dowet means that we have 2 electrons in the outer, or octet we have 8 electrons. In this case of fluorine, we have, or fluoride ion, we must have 8 electrons. So without any thinking, the right answer will be the last one here. We have here 8 electrons and negative sign brackets surrounding what? Surrounding fluoride ion. So the last one here is the right answer in our questions today. Okay, we reaches to the end of this group of questions. Okay, I hope you enjoy this part of questions of Egyptian Knowledge Bank. Please try to study hard our questions and try to mention if you have any problem in solving. Please write it below the video, and I hope you enjoy our questions today. We will continue the second part of these questions. Okay, keep in touch and study hard for this term. Okay, goodbye.